This video is sponsored by DFRobot. Hello YouTube and welcome to Heathen Hacks. If you're here from the previous video, glad to see you back. I assume that you've just finished project number 8 and have learned quite a few additional things. If so, let's move on to project number 9 or light sensitive LED. This project is one of the easier ones in terms of coding because the way the ambient light sensor or photodiode works is pretty straightforward, I think. When the sensor detects light, its resistance changes. The stronger the surrounding light, the lower resistance value it will give, and by reading the sensor value, we could make it work with various components such as a light bulb, or in this case, an LED that would automatically turn on when there is no light or when there's a lack of it during nighttime. Let's go! Here are the things that we're going to need for this project: the DF Arduino board, prototyping shield, male-to-male jumper cables, 5mm LED, 10k ohm resistors, 220 ohm resistors, and of course, the ambient light sensor. Now let's proceed to the wiring phase. Let's get our DF Arduino board, mount a prototyping shield on top of it, connect the LED right here while remembering that the LED's anode is on the right side. Connect the 220 ohm resistor to the LED's anode, attach the ambient light sensor right here. Take note that the sensor's anode is on the right side. Connect a 10k ohm resistor to one of its pins. Connect the other leg of the resistor to 5 volts. Connect the ambient light sensor's pin where the resistor is connected to DF Arduino's analog pin number 0. Connect the ambient light sensor's other pin to ground. Connect the LED's anode where the 220 ohm resistor is connected to DF Arduino's digital pin number 13. Then connect the LED's cathode to ground. Just like that. Okay, let's connect the DF Arduino board to the computer. Here's the sample code that DFRobot has provided. Make sure that the MCU is being detected and we're using the correct board. Click on verify, then upload the code. Alright, let's open serial monitor. It says here that if the value is less than 1000, the LED would be off and vice versa. And as you can see, the values on the serial monitor is above 1000, so the LED is turned on. Let's turn off the lights to see if the value would change, okay?
What? Why are there no changes?
Alright, let's move this right here. There we go. Well, still not changing. Okay, what if we connect the ambient light sensor's cathode to where the anode is connected? So it's either the orientation on the PDF is reversed, or the pins on this specific ambient light sensor are reversed.
Interesting. As you can see here, contrary to how the sensor is attached on the PDF, I connected mine the other way around before it started working properly.
So if you turn off some lights, the values on the serial monitor gets higher, which is a good sign. Well, it looks like the value is about to reach 1000, so let's turn off more lights. And there we go. Did you see that? Let's turn on the lights again, and the value suddenly dropped. Let's turn off some lights again and then cover the sensor using our fingers, and there we go. Whoop! 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 Well, that's pretty much it, really. If the value is less than 1000, the LED turns off. And if the value is greater than 1000, the LED turns on. The code is really simple, I think, and we're already familiar with everything in it since we've discussed those on previous projects. So I don't think that I really need to explain how it works again, right?
Yeah, thought so.
So for a more in-depth explanation, please refer to the PDF. Click right here if you feel ready to move on to the next project. See ya!